It's so nice to be back with you all again. So a little bit of history into this talk. I have always been a monolithic developer. In all of my engineering roles, I was always working on monoliths. And I always had this little fascination about microservices. And then I moved into developer advocacy, and I wasn't able to go ahead and play and learn, but I went to lots of talks. And I want to share some of my experiences with you and hopefully unlock some knowledge that I've fought to gain. So let's get started. I don't need to hang out on here because Laurent has already given you all the information, and you can see I've enabled dark mode as all the cool kids do. But let's have a think. You've decided you need microservices. We've all been there. We've been to see the talks. We're like, yep. I need microservices. I need all that scalability. I need all that bells and whistles goodness. Are you sure? Really, just before we go any further, I want you to stop and really think about it. If you can definitively tell me, yes, we need microservices, then you're good. But if you're like, I think so, I'm not really sure. I think we do. I think it would be good. And I'd really like to play with it. Then stop right there. You can carry on watching me, but just stop your microservices implementation just there and think a little bit longer before you go ahead with it. But let's consider that you are the former there. And you've definitely decided that you need microservices, that you are going to have this infrastructure and this architecture, and you're going to take it on. Okay. The first thing that came up to me was, what is all this gobbledygook? Now, for those of you who don't know what gobbledygook means, that means really weird names and unintelligible stuff. I went and started looking at all these services that I needed, and I'm like, I don't know what all of these things do. We did see some of them in Andrea and Marco's talk earlier. They were talking about Zipkin and Prometheus. Try Googling Prometheus. All you get is alien movies, okay? I tell you, it's not easy to find information about all of this stuff. Then there's, where do you start? What do you do? How do you actually tackle starting development on microservices? How long is a piece of string? How do you tell your project owners, your managers, your team? How do you start going about it all? And, you probably want to do a proof of concept and things like that. It's just overwhelming, I think, is a really good way to describe this. So hopefully I'm going to give you a little crash course on some of the basics. Let's start with some of the gobbledygook terms that we have. The first one that comes up often is service registry, or sometimes called service discovery. And this is really how application services locate each other. If you've got lots of different services, lots of instances of those services, how do you know where they all live on the internet? Now, the next one, API gateway, that's probably more familiar to you because that's not a distributed system specifically. That can be used for lots of different aspects in web development. But this is a server that is a single entry point into your system. It's the only way in, and there's lots of benefits to that. Again, load balancer is probably quite familiar to you. This is how you can distribute traffic across all of your different services, or more to say the implementations of different services, because you may have lots of implementations. External configuration, I didn't even know that was a thing until I started to research distributed systems and microservices, and this is actually really cool. This is a centralized place to stick all of your configuration, so all of your services and implementations can just go there and get it. It's a single place of truth. It's an easy place to update things, so this is a good thing. Now, circuit breaker, I was like, oh God, yet another pattern. I know a lot of patterns in development, but I was like, okay, I don't understand this one. But let me try and explain it to you in a very loose term. If you've got a service over here and you've got another one sending requests to it, If this service goes down, this one doesn't know. It keeps sending stuff to it, and your service is going, I can't do it. Blah. It fails, it stops, it doesn't enjoy it anymore. That's it, service has gone down. If you have the circuit breaker pattern implemented, you have this other little service sitting there and going, that service isn't dealing so very well. Let me take some of those requests away. And it starts to store them so they don't get lost. This gives the other service a time to catch up with itself. It can sort its stuff out. It can be like, okay, give me a few. And the circuit breaker can start feeding those requests back through to it. And then once it's resumed its proper way of working, the circuit breaker can just step out of the way and normal service resumes. So that's a very loose way of describing that pattern. Now, the last one on my list is bounded context. You hear this bandied around all the time. So the technical term is the boundary of a model that represents its concepts, relationships, and rules. I like to think about this as I've got service A, service B. They share a model. It's a user. And that bounded context is the shared properties between there, the things that they need to talk to each other about. So you can think about it kind of like that. All right. So this leads you onto the question of where to begin. And this is really hard. You need to discuss this with all the stakeholders, the team. You need to consider all the different options. So before you even write a line of code or refactor a line of code, you need to think about this. And this is why taking on this architecture is not for the faint-hearted. Do you start with a fresh start? Do you refactor existing code? How do you deploy it in stages? So maybe you take a little bit out here and there and you sort of limp your monolith on for a while. So these are things that you need to really have clearly defined before you start. Now, in my quest to find more knowledge, on my Twitch stream, I started the Tanzu Tacos application, and I can share you links to this. And this is my journey of discovery through this whole architecture and new world. Now, this all comes out of my head, but let's consider it in truth. It's an e-commerce food ordering site because I love food. Things go crazy on Tuesdays. Why do we think they go crazy on a Tuesday? I'll leave that for you to answer. Now, we want to scale to meet business demand. And we also want to be able to easily add in new services like order tracking and all these sorts of things. So let's consider our monolith at the moment. It's a pretty standard looking monolith. We have a user interface, data access, ordering, payment, identity, notifications, admin, catalog management, and all that stuff. So it's all in a monolith. Now, we may have tried to do some stuff just to get it going and maybe take some of the burden off the server. So, I mean, this is quite common. You've taken customer client application out. So this is now a Blazor app. This burden is now on the client browser. So our server's not really having to do much with that. Notification service, that may have been pulled out and put into Azure Functions, for example. This is a really simple, confined thing to extract from your monolith and throw off to another place. So we've got this to begin with. But before we go any further, I really want to talk about scope. This is the key thing when you are coming into looking at the architecture and how to plan out your services. And it's really important to remember. Now let's go and have a little look at our food truck. Currently, we're selling tacos. Now, how about we start selling hot dogs and burgers and pizza? And let's have some noodles and rice, sushi. And now we're going to start selling desserts. Would you want to go and eat that sushi? Do you think that this little food van can do all of these things well? I'm not so sure. So when you are designing your systems, you need to make sure that a service does one thing and it does that one thing well. Now, I just want you to sit on that for a moment. And this really needs to be your guiding principle as you go through and architect your systems. Now, I often get asked, oh, but how big should my microservice be? How many lines of code? Because we measure things in lines of code these days. But I think as long as your service is within its scope and it's doing its one thing and it's doing its one thing well and it's not doing anything else, it doesn't matter about its side. It could be a minimal API with basically a single page, or it could be quite a hefty application with lots of logic in there, because that's what it needs to do. So just consider that as you go. So we have our monolith. Let's have a look at the scope of each service with this in mind now. We have the customer UI. This displays food items and collects orders. So it is just that go-between with the user. We have a food service. This is just dishing up a catalog of items. We have our order service, and this is just going to deal with orders, and it's going to push them off to the payment service, and that's going to deal with all the payment. That's the service that's going to talk to the third-party service about actually putting the payments through. And then we've already seen that we've pulled our notification service off. I'm not going to talk about the other aspects of it just yet. These are the core things that we're going to look at. But what does this allow us to do? Well, it allows us to scale everything really independently and meet our demands. Okay. So the first thing I'm going to touch on now that we've sort of thought about our scope is communication. This is the first thing really that our apps need to do, isn't it? They need to talk to each other. How's the food service going to talk to the web UI, or the order service tell the payment service that it needs to take a payment? Right, so synchronous communications. I can hear you all like yelling at me already, because synchronous communications, HTTP, gRPC, SignalR, TCP, these are all considered synchronous. And you're like, wait, Layla. Wait, when I do HTTP requests in my ASP.NET Core app, am I allowed to call it .NET Core? I tell you, it just rolls off the tongue. I put async and await in there, and it's asynchronous. You've got this wrong. Well, consider it from a bird's eye view. We're looking at our communication. I make a request to a service, and I am waiting for a response. I'm not going, yeah, here's a request, I don't care about the answer. Therefore, it's considered synchronous communication, because I am waiting for a response, whether that's a 200, a 203, whatever it is, I am waiting on that response to do something. Which leads us to asynchronous communication. And this comes in the forms of queues, and that's one-to-one communication. So that's very, limited. And then we have buses. Sorry, my asthma is very bad today, so I do keep coughing. This is really good for one-to-many communications, and there's a lot of things that go in around this type of communication, and I think it's actually really interesting. But we're not going to touch on it today, because that's a whole talk on its own. Alrighty, so in the context of our services, how is everything talking to each other? Let's consider the customer client and the food service and the order service. When our users come up and they request to see what food we've got available, they don't want to wait around. They want to make a request and get a response. So this is all going to be synchronous, okay? You don't want someone going, is this food catalog ever going to load? I'm really hungry. So this is all synchronous, and that could be HTTP, whatever you want, really. So this comes to our backend services. We have our order service, and that was talking to the front end by HTTP. But when it talks to everything else, it doesn't care about a response. It's only going to say, this payment needs to be taken, and it pushes a message out onto our publish and subscribe system, and it doesn't care now. It's like, yeah, go and process payment. It doesn't need to wait for a response. Our payment service is just going to listen out. It's going to subscribe for any messages that talk about payments. And this all comes into topics, and there's lots of ways that you can manage your queues. And as I say, that's a story for another day. And again, the notification service is going to be like, yeah, okay, you want me to send a notification, it will do that. And when the payment service has processed a payment, it's going to say, okay, this order's been processed. It doesn't care if the order service has picked it up or not. It just publishes that. And the order service is like, oh, I was looking out for that order. Oh, it's been processed. Awesome. And it can go on like this. Right. So there you can see the whole system. And this is maybe as we start to scale it out. The admin site may be talking just to the food service because it's updating that. And that may be some kind of synchronous communication there. Our kitchen service may just be listening out for messages from the order service that puts them out when orders have been processed through payment. But it may want to talk to the kitchen client through Signal R. So you really have so much flexibility to control how everything is talking to everything else. So I think that's really interesting from a system point of view. Data and what to do with it. This always comes up and it always causes strife. Here's our system. And guess what? We have a big old bucket of data, don't we? You know we do. We are monolithic developers. We've just got that one big relational database with all of our data in it. But that's not particularly scalable. And that's really coupled to everything here. And we want loosely coupled systems. So that means that each service should have its own database. And I do see a lot of pushback on this. When I've been, doing implementations of different datas on streams and talking about this, a lot of people really do push back on this. But consider this. If I have a food service, well, that doesn't need much. It doesn't need a relational database. It's just a catalog. That could be just table storage. It's cheap. It doesn't need updating very often from an architectural point of view. We have a payment service that could be very high volume. Maybe we want something that's highly scalable. So maybe we're using Cosmos DB and we've got lots of redundancy. That's expensive. We also have our order service. Well, that's got user data. That may be more of our traditional relational database. So you can see we can make everything very specific to the needs of each service. And guess what? When I update the model of my order service, I don't need to migrate those changes to any of the other services, because remember, these services may be managed by other teams. I don't want to have to go and say, sorry, folks, I changed your complete, entity model. Here's the migration. I'm really sorry. And just slink back out of their room. You want everything to be nicely isolated, very loosely coupled. Always maintain that it should be loosely coupled. Now that comes to the point that people struggle with, and I struggled with this. How do you make sure that the data is the same across all databases? And that's a consistency model called eventual consistency. And this is used in distributed systems. And this says that if no new updates have occurred, that all the data across all of the databases will eventually return the same data. Okay, and it's the last updated value. They'll all be consistent across the system, but it does take a little bit of time. I mean, not like months. We're talking really quickly here. Okay, security Q, the silent groans. I can hear you. I really can hear you from here. There's two sort of things that we need to consider here. When someone comes and looks at your site and wants to order something or wants to browse your catalog, we don't want them to have to log in. We don't want that barrier of entry for them to browse all of our food. So we need to consider machine-to-machine security, because we don't want any old app to come and access our catalog. We only want our app to access it. So this needs to have some kind of authentication going on behind the scenes. So that's why we use machine-to-machine. And then for the user, when they actually want to come and order some food, we just use the sort of normal authorizing and authenticating via a sign-in that we'd be used to. Security options. I say this is a vast topic, so we won't go into that, but you've got cookie, which is client web apps, stores the cookie. If you've got you can't store that cookie, you're going to use token and claims. You may use an IAM, which is a, oh God, why do I always have to look this up? Just, these things just do not stick. It doesn't matter how many times I say to myself what that stands for, I still have to go and do identity access management. I know what it is, I just can't ever remember the acronym. So this could be your OpenID, your OAuth, Azure AD, whatever you want. It can manage a lot of that for you. Check out the 45 show on Twitch with the all the stuff about Azure if you want to learn more about that. So the one thing I will say is don't roll your own. Definitely don't roll your own. Use something that's out there, and just make sure it's robust. This is a really important aspect of your system. The next one we're going to look at is the API gateway. And what is it? We loosely spoke about that at the beginning. And this sits between all of your back-end systems and your front-end system, and all traffic routes through this. Now, you don't necessarily have to use an API gateway. You could just have all your services spoken to directly. You could use a back-end for front-end, lots of different things. But we'll just talk about the API gateway for now. This is a reverse proxy, and it's a single entry point to your system. That means it's quite easy to secure because all your traffic has to come through here. It's your single point of access, and this makes your system more robust. You can do a lot more things then with your API gateway. You can hook it in with other cool features that you're going to need, such as service discovery. And as I said, that's sometimes called a service registry as well. Now, you can hook all of that into your API gateway, so your gateway knows where everything is, because without knowing where all of your services and your instances are living, what port, so to speak, how is anything going to route through and talk to anything else? So this is another really key feature when you've got all these distributed systems, is telling everything else where everything else is. So there's a lot of options for this. Here are just three of the most common ones. You have Eureka, which is AWS Service Registry. That is built on Spring and Java, but you can easily use that in a Docker container and things like that. It also offers you the load balancing and a whole load of other bells and whistles, as do all of these really. You've got Zookeeper, and we've got Console from HashiCorp. So I guess choose the one that has the features that you require. You may not need all of the bells and whistles, you may just need parts of it. So, and I mean, there's a whole load more than these ones. Now, actually writing code, what are the things that you need to bear in mind? Well, you need to plan the scope of each project. I hope I've drummed that into your head so far, that you must plan scope. Plan the scope. And plan the right solution for each project. If a particular project should be written in Go, write it in Go. And that leads down to that one just below that one, which is be flexible. Don't get stuck in a rut. Don't get stuck on one path. Keep your mind open to better solutions and new ways of doing things. This kind of development really lends itself well to agile thinking, failing fast, really keeping everything moving and enjoying your development. And then just layering complexity, because these things are really complex systems and you just want to layer that in. Add a bit of complexity, test it. Layer in the next bit, test it. Just really and have tests. While we're talking on tests, make sure you have them. Other stuff, because this topic is vast and this really was a whirlwind around it. Things we haven't covered: deployment. Yeah, that's a really big topic that I am not going to wade into. monitoring, we saw some of that earlier with Andrea and Marco. So, you can use things like OpenTelemetry. You need to monitor all the things. You've got so many services going on here. You need to be monitoring them. Availability, so coming up with your scaling and load balancing plans, how you manage that. And there's probably a whole lot else that you need to consider that we haven't covered here. Some resources for you to check out. Steel Toe, a bit biased, I work with the team. A collection of libraries to help with connecting services such as Eureka, RabbitMQ, and all the observability endpoints. That's actually built on top of OpenTelemetry. We have Dapper, lots of hype around Dapper, and that's the no P and an E and no E, different from the Dapper of old. And this helps developers build event-driven, resilient, distributed applications. Got Project Tie. I've not tried that. It is in pre-release, but it's very popular. Lots of people do it, but I haven't got around to trying it. Yarp, that went GA on Monday. This is yet another reverse proxy, and it was developed by some folks at Microsoft. And I have found this like a really nice tool to use. So those are some lovely libraries for you to check out. And that's it from me. I do want to just show you some stuff on there. If you want to reach out to me, you can find me on Twitter at Layla Codes It. You can email me at laylap@vmware.com. You can find me on Twitch at Layla Codes It as well. And then just to be awkward, I'm Layla-P on GitHub. Now, if I just come out of here, I have been building out Tanzu Tacos on stream. It's still a work in progress. We have implemented the API gateway so far. Go away, Windows thingy-mabob in the corner. So you can come in and see it. It's not fully documented. We're still working on it. It runs with Eureka, it has Yarp, it has RabbitMQ. So if you want to go in and have a look at that, there's lots of stuff in there. If you're interested in Yarp, I've got some content coming out. I've built some stuff with just adding Yarp with dotnet 6 and adding Yarp and Eureka with dotnet 6. They're all on my GitHub. You can go and have a look at that. There is content coming out imminently on the VMware Tanzu developer site. And I'm going in and trying to create lots of knowledge and sharing knowledge with you. So let me just pop that back up. And there we go. Oh, Laurent, you're here with me. I hear I have a question.
I'm back. Yes, you do. And in fact, why don't I just remind people that they can ask their question on #.NETConf. So if you have any question during the course of a session, don't hesitate to put it there, and then we can ask the question. And the question that we have from Jose Barreira, who is talking about different types of DB. So he says, with different types of database, or even the same type of database across all microservices, how do you recommend handling reporting that requires data from different DB? Which is a tricky question, right? Because again, distributed architecture.
It is. So there are different thoughts on this. So if you had a reporting system, it could have its own database, and it can go and you could have your other services publishing their updates, and it could be listening to those updates and updating its database. So it does get a little bit tricky. You generally would not want that reporting service to query other people's databases. You don't want that. You want everything to go through the pub sub or however you're doing your communication, and you want to be serving the data you require up to the server. So that's the one thing I would say, is that you'll probably have a centralized database collating all the information for you.
Amazing, amazing. So everybody can continue to ask questions on #.NETConf. And like I said before, I have the .NET bot with me. So he was very interested in your session, just like our good friend Danny Declaire, who posted that he was watching you, and also Braun, who said that she was really sleepy, but she wanted to stay awake to see your session. So hopefully they were really happy to see you talk today. This is absolutely amazing. I'm going to put back your details on the screen so that people can write to you, tag you, and of course also check the code that you have been coding for us, and also on your live stream on Twitch. So thank you so much, Layla, for being here today.